Okay, so I'm going to continue to look at these problems. I haven't, so just right off the bat, I have not looked through and found the answers to these problems. I don't think I've looked through this one particularly. And I'm doing that a little bit on purpose because I want to just kind of walk you through like how I would look at a problem the first time that I see it and see kind of like how do we approach a problem, how do we like decipher it, and then how do we start coding with it. And again, I'll try and break this up into parts and write down my little timers here so I don't have to look through it later. Okay, so yeah, so again, I've added these skills covered thing in here that won't, of course, be in the exam, but I kind of want to give you an idea of what to expect for each one. Okay, and I'll probably pause a little bit, just kind of cut out my reading parts, but yeah. Okay, so this is just going to be a body mass index thing, so we're taking in a few values, taking in, what, three values? No, two values, right? Height, weight, and then we're going to calculate their body mass. Okay, so this is just a little kind of function, would be like a, probably like a method in Java. But yeah, so we're going to take in a, yeah, taking a height, taking a weight. We're just going to, this kind of X is just kind of like a dummy value. It's like just like a temporary value. We don't actually need it, but they're going to use it to kind of, anyways, looks good here. And we'll return this. Okay. Cool. So the first, I mean, right off the bat, this is just a simple kind of understanding the code, worth only 1 point. So it's just a quick kind of check-in problem here. Just pull this over. Oops, that's not working. Okay. Anyways, so we're gonna figure out the body mass of Boris here. So we need to let's see, we need to say height. First parameter is gonna be height, so height's 2.0, and then weight is 104. And so we could just calculate directly. B is going to be equal to W divided by H squared, but I'll take it step by step and say X is equal to H times H, so that's going to be equal to 4. B is going to be equal to W divided by X, so that's going to be equal to 104 divided by 4. I'm interested to see, and now what I see here, maybe an important point here, and I think I'm right about this, is that this is 2.0, so that's going to indicate that it's a double. So I'm going to say that this should be 4.0 and this is going to be 4.0. So, and I'm curious to see if this is correct in the answer key. Because we've seen a lot of things where they just do integer stuff. And maybe it won't make a huge difference here. Because normally they don't like to, like in Java, you have to cast between integers and doubles. And typically I haven't found that much in these IB exams. But that's something to look back on and see kind of, are they looking for decimal answers? Do they not care? I guess in this case it's really not going to matter. So 104 divided by 4, it's like 52 divided by 2, it should be 26. So B should be 26 here for A. And let's look through for B. Okay. I don't think, yeah, I'm just a little bit curious about this 2.00. I don't think it's going to make a big difference. Hopefully, I don't think they're going to care too much. But in that last one, we were like trying to find the average on the first practice problem we did. We had to find the average, and that like dividing by 2, it was integer division. So it does matter a little bit. I'm kind of curious to see how they approach that here. Typically, if there's decimals, it's a double. So we're gonna include decimals going forward here. Okay, so BMI. Pause this again. Okay, so let's look through B here. So we're going to construct an algorithm. So there's going to be a higher level, and let's see what kind of points we're looking at for this one. 4 points for this one. Construct pseudocode that accepts the person's body mass, accepts the person's BMI, and then, oh, so this is just directly related to this one. Oh, okay. All right, I think this stuff is related to part C, and I think this is kind of related to part B. So use pseudocode to construct them, and then outputs the weight category that they belong in. I'm a little bit surprised that this is a 4. That's why I'm kind of struggling to understand a little bit here, because we already have this is for a BMI, so we've already constructed that. Accepts a person BMI. I thought this one, since it's a 4-pointer, would include more of this stuff. But I think that's going to be part of CDE. Anyways, okay, so, alright, let's look at part B by itself. Use pseudocode to construct an algorithm that's going to accept the person's BMI, and then it's going to output the weight category that they belong into. It seems like this is really very simple. Maybe I'm wrong though. Okay, so it's going to take their BMI. So we're going to say if BMI is less than 18.5, output underweight. I feel like I'm missing something here. I'm going to have to check the answer key directly after this, because I feel like This just seems a little bit... Oh, then again, I can't even spell else correctly, so maybe can't really talk there. I mean, we could do this a bunch of different ways. I'm going to do this as if and else ifs. There's a couple different ways that we could do this. So this should be fine, because basically as we look through here, like as soon as a person is caught within an if statement, like it's going to exit the if evaluation. So for example, if our BMI here is, like our BMI, say we have a BMI of 15, well, that's going to be under for both of these. So it seems like there might be a problem, but it's just whatever the first one, whichever if statement catches it first, that's going to be the first output. So if we put in a BMI of 15 here, then it should just catch this underweight one and then exit the if evaluations. So if otherwise, what we could do is do like a compound thing here and say, well, you know, for this one, if the BMI is greater than or equal to 18.5, but less than 25, then it's going to be normal. If it's So we could make this like a compound statement. I think this should be fine. We'll check the answer key directly after this one, because I feel like maybe I'm overthinking this, but I feel like for 4 points, this is not too bad. Less than 30. I'll put overweight. Ugh, I don't know why I can't spell. I actually can spell, but just not working out today. And then otherwise, if it doesn't get caught in any of those, then we can just output obese. I have to look at the answer key directly after this, because I really feel, am I like really this bad at spelling? I actually am a native English speaker, I promise. But sometimes I surprise myself. Let me take a look at the answer key here. Okay, so actually, I'm just gonna pop right down to here. Answers. Yeah, so they did some category stuff in here, but I don't see that included in here. So I think what I have is fine. Like, I'm a little bit shocked that this is worth 4 points. But okay. That seems like that's much easier than some of these other problems. But, okay, let's move right on to C then. Like, that was fine, I guess. I'm a little shocked. I really felt like I was missing something, but I guess it's a good reminder not to overthink things. Okay. All right, so C. All right, so C is going to be a little bit more complicated here. This is where I felt like, okay, this actually deserves points. And you can see this, like, constructing this algorithm is going to be worth 6 points. So let's take a look through here. So basically, we're keeping 3 arrays, and we're trying to keep their weight, their height, and then their name. And they're all kind of organized, so like whatever's in position 0 in all 3 of the arrays, like that set of data goes together. So name 0 is going to be the person's name, their weight's going to be weight 0, and their height's going to be in height 0. So they're kind of organized that way. Yeah. So it's all one-dimensional array, kilograms, yeah. And so we can see down here 0, 0's like name 0, weight 0, height 0, those all go together. So the first thing we're going to do is height 3. State the name of the person himself. Yeah, so height 3 should correspond to Paul. So I'm not sure even really what they're trying to test with that one, because they're giving you literally the numbers right here. One thing they might be looking for is for students to choose like the third person. So that might be Hugh, but we're looking at index 3, which is actually going to be person number 4. So I mean, that's a little bit confusing, but considering the fact that they literally labeled them here, I hope that's a kind of give me point on that one. Let's say DI. One reason, yeah. So the biggest reason here is the reason why we can't use binary sort is because binary search is because the way binary search works is that, and it's only a 1 point thing here, so you won't need a very detailed explanation, but binary sort requires that binary search requires that the data is sorted. What the binary search does is the data is all in order, and then it chooses the middle value. So if we're looking for a height of like 1.4, we look at the middle value. If the middle value is greater than 1.4, then we're going to start looking at the left half of those values. So say like the middle value, and this is a longer explanation than this problem deserves, because it's a 1 point identifier problem, but just as a reminder. So say we're looking for our n is 1.4. or say height, I guess, since that's the actual problem. Height is 1.4. We'd look in the middle. If we find the middle, then it's 1.7. Then, okay, we don't care about this set of data. We only want the stuff on the left. Say it starts at 1.0. And then we'd look in the middle here and say, okay, well, what's the middle index value here? And in that case, it's like 1.3. And we say, okay, well, we know it's greater than that. We need to look to the right of that. We'd find the middle value here and say, based on the middle index value, this is going to be 1.6. I don't know what it's going to be, right? Okay, so we don't care about this, and we'll search right here. The middle value of this is 1.5. Okay, we don't care about this. And then we're going to look for the index value right here. Oh, that's 1.4. So that's how we'd find, like, okay, this is our value that we're looking for. The index is 7. And then we could use that to find the name. So the whole point of that, though, is that only works when the data is sorted. If it's not sorted, then then finding the middle value has no meaning because there's no like order to the data. So short answer is data needs to be sorted, and this data is not sorted. Actually, the names are sorted. The names are sorted in alphabetical order. The weight isn't sorted in any kind of order. So we could just say looking for the height. Actually, let's use big capitals to identify the array is not sorted. Okay, D2. Describe how the name of the person whose height is given could be output. So basically all you would do, describe how the name of the person whose height is given. Okay, so if you're given a height, oh, I see. So they're basically asking, if you were given a height, how would you find the name of the person? So we need to use, since the data isn't sorted, the best thing we could do is a sequential sort, or sequential, I always get those words, like, we need to do a sequential search, which basically means we're going to start at index 0 and work our way through from, I guess, 0 to 29, trying to see, like, is this the height? 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 And then if we find one where the height matches up, then we're going to find the name connected to that. So sequential search to find index of given height, and I would say in the array height, use found, and basically use that found index to find index of name. And I think just to be clear on this one, I think that's fine. But if I really want to make the greater clear about what I'm going to do here, I would say, like, for example, if height is, and let me look at the table. If height is 88, the index for that is what would you say for 88 should be 4. So find index 4 in and we'd say that's going to be Robbie. Yeah, so that's how it would work. Yeah, I mean, it's obviously a lot of problems with this. And this is, you can move on to the next one. I don't want to keep doing my time codes here, but there's obviously a lot of problems with this one because what if someone's height is 88, or what should we say? I did height. Oh, I should have done weight. So my example's bad, but I think they'd understand what I'm doing there. I put an 88 for my weight when the question is actually asking about height. Hopefully I don't lose any points on that. But the problem would be that if two people have the same exact weight or same exact height, then that's going to be a problem because it's just going to stop at whoever's first. I wonder if they're going to ask. I don't think they're, like, for 2 points, I don't think they're looking for you to find that kind of exception. Because you could do something where it's like, look through and find if there's a repeat, then say could be 2 people with this value. But at a 2-point question, I don't think that's what they're asking for. And if they did, there would be something like explain what would happen if you had 2 people with the same height. That could be a whole separate problem there. Okay, moving on to part E, last longest one. Let's take a look at that one. So there's going to be actually some construction here. Let me try and... sorry. I should probably figure this out before I do this. There we go. Oh, I got a fresh sheet of paper. Okay. Should have figured that out earlier. Okay, so for part E, construct an algorithm that's going to output the names of all the people whose BMI is greater than this group's average BMI. We're going to call the method. So we already have this. So what's good about this, we're going to call the method calc BMI in your answer. That's great because we don't have to recode this. We can use it already. And this just passes in the height and the weight value. Okay, so this isn't too bad. We're going to output the names of all people whose BMI is greater than the group's average BMI. Yeah, so all we need to do is kind of look through, we need to start a count value. Like, so basically we have, well, 30 locations in this data, starting from 0, ending at 29. And what we need to do is go through and, so start with a number, with a variable that's 0, and then kind of loop through until it's 29. Each time we go through the loop, we're going to find we'll access the weight for that index, access the height for that index, and then we'll determine the BMI. If the BMI is greater than a certain number, then we will output the name that's at that index. So, I don't think that, like, there's some things we could use in here. I wonder if it matters. We started at 0 and 29 in this one, but do we need to write an algorithm that would work for no matter the size of the array? Because it really wouldn't be that hard to do. But, the fact that they put in 0 and 29 at the end here, instead of doing like 0, if they did like 0 and n to indicate that like we're not sure how many things are in the list, then I could see writing an algorithm that takes that into account. But for this one, yeah, I don't see that they're requiring that. Anyways, maybe I'm, again, probably overthinking what should be an easy problem. Not easy problem, but pretty straightforward. So what we're going to do is we'll start just, so this is going to be E. I honestly think this one, I don't know, these are both actually kind of easy. Like the 4-pointer and this one are not that challenging compared to some of the other problems I think we looked at. So we need to start with a count. We'll say count is equal to 0, and then we're going to make a loop while, and like there's a lot of different ways we could do this. It'd be super easy to do this as like a loop while the array has something next, while like weight dot has next. So like again, like I did for a different problem, like check to see if there's another element in the array. If there's another element in the array, then keep going, otherwise stop. I'm just gonna do that this way. I think that's probably a safer choice. I was gonna do like while count is less than 20, well I guess less than 30, just to count for this, but might as well just write an algorithm that would work for any of these things. So okay, so loop while weight has next. So we're gonna check. Well, we need to pass in. We need to use that BMI. We need to use calc BMI, and we're gonna pass in. What was it? What was the first? Weight and then height, or height and then weight? We're gonna pass in height and then weight. Okay, so we need to access the height. That's gonna be here. So we need to go into the array height. I swear, like, I don't know why, I think like when I write in capital letters, I can't spell as well. I don't know. Not great. Alright, so we're going to get the height from that using I put calc in there. What is going on with me? Oh my god. Hopefully your brain is working better on the IB exam than mine is right now. So we'll get height, count, so we're accessing, and these should really be brackets since it's an array. And then we'll put in weight. So we're accessing the array's weight and height here, and we're putting in the current count, to get the weight for this individual person, for this person. So we're going to calculate the BMI. There's a lot of ways we could break this up. We could save this as a variable, like a temporary variable like B or BMI, or we could put it all in one. I'm just going to put it all in one. I'm going to say like if this thing is greater than, and we need to do, what do we want to output? We want to output people. Oh, wait, man, geez, I messed this one all up. Maybe I should not be doing this. Maybe I'm tired. Which will output the names of all people whose BMI is greater than this group's average BMI. Oh my gosh. Okay, so somehow I read that was just get the average like weight. That was going to be over like normal or something. That's kind of what I was jumping to the conclusion of. Oh my goodness. Well, actually, it doesn't. Thankfully, I caught that because there's not too great of a change here. All we need to do is okay, so now this is getting to be a level 6 problem. Now I see why this is a 6-point problem. Okay, so now all we need to do is we're going to run through this. So we just need to calculate the BMI for each individual person, and then we need to add those all up, and then we need to find the average, and then loop back through to find any BMIs that are greater than the average. So that's not too hard. So we're going to calculate. So first loop through, we need to go through and find the average BMI. So we'll kind of sum up all the BMIs and then divide by the total. And then we will, I'm going to pause this so I make a note of where I make an. Okay, so maybe you're jumping right into this. If you're jumping right into this because I marked the other one as an error, there are some things in here where I explain kind of why we do the loop the way we did it. But if you're jumping right to this, so we're just going to figure out, basically we'll go through the entire list. We're going to calculate the total BMI, so sum all the individual BMIs up, and then we'll divide that by count to get the average. And then we'll loop back through there and find all of the, get the BMIs again and compare those to see if they're bigger than the average. If they're bigger than the average, then we will print them out. There's probably a few different ways we could do this. I could make a fourth array called BMI and then fill that with the BMI values. You know, like in here, I could be calculating BMIs and then storing those in another fourth array and then loop back through that new array to figure out which ones are bigger than average. I mean, there's a lot of different ways you could do this. I'm going to do this a little bit maybe longer, a little less. I think it'd be more elegant if I made this as a separate array, because then I wouldn't have to calculate BMIs again. They'd already be calculated and stored for me. But it's just a matter of preference here. So anyways, okay, so calculate BMI. So I also need to have a sum. And that sum is going to be 0. And then we're going to do sum. So I'm kind of running out of room here. This should be So this should be, so we'll change this, and we're going to say sum plus equals, and then we said we need to go through calc BMI, and we are accessing the weight, count, comma, height count, and yeah, so we're going to go through, find all those BMIs, adding those to the sum, and then we're going to end loop, and then we're going to calculate the average. And I'm again kind of wondering, like when we start doing averages, we should be worrying a little bit about like doubles and integers. You know, I think because all these are stored as doubles, though, okay, I guess, you know, we don't have to worry. These are all stored as doubles. We don't have to worry about trying to cast them or change those values. Good. So the average is going to be equal to the sum. Oh, and also in here, we need to do count plus to increment count as we go through. Yeah, I mean, there's probably a few different ways we could do that. We could also just, instead of using count here, yeah, no, we need to use count. Yeah, that's fine. So we'll leave count like that, count plus, and we're going to do the average is equal to sum divided by count. And then we're going to need to basically just copy and paste this, but looking through to find, calculating the BMI again, and then figuring out if it's bigger than the average, then we should print out the name. Kind of shaming, but okay. I don't think we should be fat shaming in our IB, or body shaming in our IB examples, but not really my choice. Let's set count back equal to 0, and we'll run through this again. So loop while weight dot has next, and yeah, we could do new variable for count, but I'm just going to leave it as that. And we'll say, so this is where we need to calculate. So we're going to say, okay, so if this thing, if the BMI, calc BMI, weight, count, height. Nice that we don't have to code for this, that they already gave us this method to work with. So if this is, well, they're not going to care about parentheses, but I do. So if we calculate the BMI, if it's greater than the average, then output, we want to do name right, count. And then, and if, oh, and then also we still want to do, and if, but we still are going to need to do our count plus. Count plus plus and end loop. Okay, so that finally worked. Let me take a look at the answer down here. Where are we at? November 18. Let's take a look at that one. Let's see here. Okay, so they're doing a loop. So they, yeah, from 0 to 29. Kind of interesting that they're doing, this is more of like a Java answer using like the loops like that instead of using like a loop while 4K, but I think that's I mean, that's obviously fine. But they're doing the same thing, right? Okay, so they're going to get the sum and they're going to divide it by 30 like we did. We did a little bit fancier, right? Because we didn't assume that there was going to be 29 or 30 things in there. We made it to work for everything. So this is a little bit simpler. They're going to go through and do the same thing, then output, you know, end if and loop. Yeah, so same exact thing, right? Same basic idea. Yeah, really not too bad. I think we need to make sure that we are not being dumb like I did, and you need to actually read the question. Don't read the question, obviously you're gonna maybe waste some time like I did. But thankfully I caught myself, so yeah. After calculating, I think everything looks good here. I don't see any places. I feel like my code's almost the same exact thing as this, so I don't see any way that I would really lose some points here. We're doing a sum in here. Yeah. Okay, sorry, I'm gonna close it with that. I think that hit everything. I think overall, I think this one's not that bad compared to some other problems. Like I felt like this was a lot easier than I thought it was gonna be. I mean, for 4 points, I thought it was gonna be a lot harder than it was. And then in here, you know, once we read the question, and I think if you're comfortable using arrays, I don't think it's really too bad. But okay, I'm gonna stop it there. Again, always send me those questions, emails if you need some help.